looking at exercise 5C3, I was going to do question 3. Question 3, if I can show it on the other page. Right. And question 5. So first video will be question 3. This is exercise. Now it won't let me write. And I need to write. There we go. So 5C3. I need to write because I need this function. So we've got acceleration. We can integrate to find velocity. We could integrate again to find displacement. So this should be fairly straightforward for you guys because you've gone the other way before. You know that differentiating displacement gives velocity and differentiating velocity gives acceleration. So we're just working in reverse. Okay, and I think I can do the whole question without. We're going to find velocity, find displacement, functions, describe the motion. Now if I want to find velocity, so what's going to happen is that the integral of acceleration equals velocity, but the problem is when I go and find the antiderivative, there will be a plus c, and I won't know what that is unless they give me some information. So that's coming from in the question where it says the particle is stationary at the origin. Actually, I might write that down. So when t equals 0, right, we're stationary and we're at origin. So what that actually means mathematically is that the velocity where t equals 0 is 0 and the displacement is also 0. And we're going to need to know that if we want to find the constant of integration. All right, so velocity will equal the integral of this function. Let's rewrite it so that it's easier to integrate. And what I mean by that is using negative powers, because this is what I call a reverse chain rule situation. So we start with our power. It's like we're doing the chain rule for differentiation, but we're working in reverse. So we need to add 1 here. To get to a minus 2. And we need to divide by minus 2. We're going to keep that constant. Then we would look inside, and what we see is that there's just a 1t squared. Sorry, 1t. So I'm trying to take a phone call and do a video. So we don't need to do a further step really, because normally at this point I look on the inside of this function and I think, well, the derivative of t would be 1. Normally if I'm doing the derivative I would multiply by 1, but I'm not, I'm integrating, so I'll divide by 1. So we could divide by 1, but it's, you know, same thing. So just to tidy this up, we've got 2 divided 2, so we've got minus 1 on t plus 1 all squared. And we have to remember there's a constant. And I should have written it on this side as well. All right. So we know that when the time is 0, we're stationary, which means we're not moving, which means our velocity is 0. So if we use this new function we've got, 0 plus 1 all squared, that's just going to be 1. plus c, and it's got to equal 0. So you end up with minus 1 plus c equals 0, or c equals 1. Okay, so if I can try to remember that and write it somewhere so that I have a velocity function set aside. At this late stage of the day, I don't trust myself to remember. So the velocity function is minus 1 on t plus 1 squared, and I've just worked out that the c was a positive 1. Okay, now I can erase this. All right, next step was to find the displacement function. So displacement, using the letter s, we can find that if we get the integral of the velocity function, and the integral of velocity is the integral of this. I'm going to rewrite it, minus 1, using negative indices so that it's easier to find the antiderivative. And I've got a plus 1. The whole thing needs to be integrated, hence the brackets. So the antiderivative will look like this. So we need to add 1 here, t plus 1 to the minus 1. We'll keep this constant even though we're about to get a negative divided by negative, because the next step is to divide by the new power. Then we would look inside, like before, we think, well, the derivative of t is 1, but we're not finding a derivative, we're integrating, so we're going to divide by 1 instead of multiply, so this is times 1, which is just, 1. All right, over here, the integral of 1 is t, all right, and there's a possible constant, and my pen's playing up. So now what's happening here is we've got a displacement function minus 1 divided minus 1, that's just 1. So we have 1 on t plus 1 plus t plus c. We know that this object started at the origin. That means that at time 0, the displacement was 0. This has all got to be 0 when t's are 0, so we could say therefore 1 on 0 plus 1, which is just 1, plus 0 plus c has to equal 0. So we're left with c equaling minus 1. Right? This will be a 1. I need to subtract 1 from both sides. There's your c. So if I can put all this together over here, we have a displacement function now. 1 on t plus 1 plus t, and this time it's a minus 1, not a plus 1. All right, let's make that bigger. Then, the last part of the question wanted to know, at time equals 2, describe the motion. All right, so maybe we start with displacement. What's the displacement when the time is 2? What's the velocity when the time is 2? What's the acceleration when the time is 2? Okay, which we can do pretty easily because we have all the information. So if we put t equals 2 into displacement function, plus 2 minus 1, we're going to get, well, 2 minus 1 is just 1, plus a third, we get 4 thirds. And I've just realized that I should have been writing units with these functions. This is meters per second. So that's in meters. Velocity when t equals 2, we'll get minus 1 on 3 squared. So if t is 2, we're getting 3 squared, that's 9, plus 1, so it's like 1 minus 1/9, which is 8/9 meters per second. And acceleration, we're putting a 2 in here, so we get 2 plus 1 is 3. 3 cubed is 27. I'm just going to go straight to writing the answer because that one's fairly straightforward. 2 on 27 meters per second squared. describing the description, we'd say object is 4 third meters to right of origin. Okay, that's coming from this. It's moving towards the right or to the right. That's because this velocity is positive, right? You can write down the velocity if you like, and it's accelerating as well, and its velocity is increasing. That'll do. Velocity is increasing. We could say its acceleration is 2 on 27, something like this. Its speed is also increasing. If it has positive velocity and also positive acceleration, so it's accelerating in the same direction that it's moving, therefore its speed is increasing as well. But you don't need to write that unless you're specifically asked. Okay. All right, and that's it.